Here we have a SAT math question on exponential function. Okay, let's go the stuff. There is an exponential function given over here. There is f of x equals to a times b to the x to power. And also we have f of n negative 1 equals to f of n positive 0.72 times f of n negative 1. Okay, now let me take the stuff over here. That is f of n negative 1 equals to f of n positive 0.72 times f of n negative 1. Okay, here when I look at the term over here on the left side and the term over here on the right side, so both these terms, these two terms contain f of n negative 1. So we have to consider these two terms as like terms. So we can combine them. So for that, I subtract 0.72 times f of n negative 1 from both sides. Let me do it. So 0.72 times f of n negative 1. So when I do so, this positive value, negative value will cancel out on the right side. On the left side, I'm getting f of n negative 1 negative 0.72 times f of n negative 1. On the right side, we just have f of n. Okay, here we have an expression on the left side. In this expression, we have two terms, and both the terms contain f of n negative 1. Okay, now let's assume a similar expression to this one. Instead of f of n negative 1, I just consider some other stuff like something like a. That is a negative 0.72 times a. So at the place of f of n negative 1, I just consider a. So instead of a, we can just consider this one as just 1a, because for any English alphabet, if there is no any number in front of it, we have to assume there is 1. So we subtract 0.72a from 1a. So what can we do? So here these two terms contain a. So we can factor a out. If I factor a out, what I will be getting? So I'll have 1 left in the first term and 0.72 left in the second term. So a is factored out. So when I subtract 0.72 from 1, I'm getting 0.28 times a. So the simplification of this expression equals to 0.28a. Okay, the same thing we can do over in our problem, that is for the expression we have on the left side. So that is when I simplify this expression, I'll be getting 0.28. So here we have a, so that's why I'm writing 0.28a. But instead of the a at the two places over here in our expression, what do we have? We have f of n negative 1. So instead of 0.28a, we have to write 0.28 times f of n negative 1 equals to f of n. Okay, so from the given information, we know that f of x equals to a times b to the x to power. But here what do we have? F of n negative 1. So at the place of x, we have n negative 1. So if I want to write an expression equivalent to this one, I have to take this a times b to the x to power. But instead of x, we have to write n negative 1, because we have n negative 1 at the place of x. So then I'm getting 0.28 times a times b to the power. So we should not write x. Since we have x, here we have x. But in our problem, instead of x, we have n negative 1. So for the exponent of b, we have to write n negative 1. So the same thing we have to do for f of n. So for f of x, a times b to the x to the power. For f of n, you just have to replace this x by n. Then I'm getting a times b to the nth power. Okay, now let me write the equation over here. That is 0.28 times a times b to the power of n negative 1 equals to a times b to the nth power. Okay, here both the left side and right side of the equation contain a. So and also it's in multiplication with the other stuff. So better we can divide both sides by a to simplify. So because our aim is to get the value of b. So when I divide both sides by a, this a will cancel out and here a will cancel out. Then the equation becomes 0.28 times b to the power n negative 1 equals to b to the power n. Okay, now let's consider the quotient rule of exponent. What is the quotient rule of exponent? Okay, now let me think about it. The division of two terms with the same base. That is, I divide the a to the mth power by a to the nth power. Here the base is a, here also the base is a. So I divide two terms with the same base a. So whenever I divide two terms with the same base, what I need to do is I have to write the base ones and I have to subtract the exponents. Then I'm getting a to the power m negative n. This is called quotient rule of exponent. Okay, now let's think about the quotient rule in reverse order. That is, here we have base a and we have two values in subtraction of the exponent. So whenever two values are in subtraction of the exponent, what I need to do is I have to take this base a separately for each exponent and divide them as we have on the left side. So because here we have the base b and at the exponent we have two values are in subtraction, that is n and 1. So what I need to do is I have to take this base b separately for each exponent and divide them as we have over here. Okay, let me do it. So 0.28 times b to the nth power divided by b to the first power. Okay, so whenever the exponent is 1, we don't have to mention, simply we can write as b. So equals to b to the nth power we have on the right side. So here we have b to the nth power, here we have b to the nth power. On both sides we have b to the nth power. So I think we can get rid of this b to the nth power. So for that, what I need to do is I have to multiply both sides by 1 over b to the nth power. Let me multiply both sides of the equation by b to the nth power. When I do so, this b to the nth power, this b to the nth power will cancel out. The same thing will happen here. Okay, now let's simplify the stuff we have on the right side. So here it's 1, we have what as in that is b to the nth power goes into b to the nth power 1 times. 0.28 times 1 is 0.28. Again, if it is multiplied by this 1, we get 0.28 in numerator. And in denominator, we have b. On the right side, we just have 1. Okay, now our aim is to get the value of b. So let's get rid of the b in denominator over here. For that, I have to multiply both sides of this equation by b. When I do so, this b will cancel out. I'm getting 0.28 equals to 1 times b is just b. So now I got the value of b. The value of b is 0.28.